how suitable is the chemical recycling technology depolymerisation that you specialize in? How suitable is that for polystyrene?
Yeah, thanks. Just to follow up on Jens's comment, I think one of the reasons why we see a lot of interest for chemical recycling technologies is because mechanical recycling alone sees a lot of limitation in the market access. It's very difficult. It's not because we're not able to extract it. I think optical sorting and different types of mechanical equipment can literally extract polystyrene from the mixed stream. I think that's doable. Now the second part is, who are you going to sell it to? And I think this is what chemical recycling is addressing as a question, is if we're not able to sell it as polystyrene, now can we break it down into something that can sell in a much bigger market, which is styrene market, and that's a commodity-driven market. And so this is what chemical recycling is all about. So we're taking polystyrene that usually comes from a mechanical recycling facility, doesn't need to be so washed up or cleaned that much, and then we apply a thermal process in our case, and there are other technologies out there that are doing that. And we're essentially leveraging the unique specificity of polystyrene, where when we break it down into styrene, and the styrene itself is a liquid. If you look at other types of some of the major resins out there in the market, they will either return into a gas form, like if you talk about polyolefins, the monomer itself is a gas product, or you're going to have to go through an intermediate product, which is a naphtha, and then have to recrack it a second time. So it's adding a lot of complexity on these things if you want to return it back to the monomer. Same thing with the PET. PET has a different problem where you have two monomers in this case, and then it involves a different chemistry where sometimes you need reactants and whatnot. And one of the monomers is a solid. So having to deal with a solid monomer, purify it, remove some of the contamination may be more difficult. Now, when you go back to polystyrene, you can really appreciate the value of dealing with a liquid monomer. So having this liquid monomer, it's very easy to purify it and get it back to 99.8% styrene just by distillation. And doing that, then you're able to really enable true circular economy and return it back up in the very same process that you would use for virgin polystyrene manufacturing.
So you're actually saying it's very easy to be recycled?
Well, yeah, it's probably, from our perspective, I'm not in the God's secret for other processes, but just from a macro level, if you look at the number of different products that you have in the market, let's talk about this 6 or 7 major resins. I think polystyrene is the easiest one to recover back into the monomer form, because the monomer is a liquid. And I think that's really a unique property of polystyrene here that the chemical recycling technologies are exploiting very well.